Okay, so hello everybody, it's week 10. All right, we had a 1 week break and then we had a midterm. We're back. We continue with our platformer. If you take a look at the code that is posted from the last lab, we have this little robot that is walking and jumping and careful, it's dying. Right, we have also the kill zone. Sorry, that takes us to the starting screen, but we have also the kill zone that is taking us back. Spawns the different scripts, right? What we did during the lecture this week, this script called screen switch, and we've added the scene, or two scenes actually. One is level 2, one is main. Main is our gameplay. Menu is our welcome screen or whatever, the screen with the start button, right? Let me show you this one, right? So just plain start button. This button has the script attached, scene switch, and from the script, where is it? It's here. From the script, we simply make a transition. That's not this one. The scene switch is here. Right, from this script, we have the function start scene. We're using application load level. We can also use scene manager. Scene manager requires additional using to be added to the file using Unity Engine scene management. And then you can load scene in exactly the same way. Now, application load level is something from Unity 4. Scene manager is a new addition in Unity 5. So they're trying to phase out the old code. I'm showing you both solutions because you can find examples that are still using application load level. Load scene has 4 different versions in total. So you can use ID, you can use name, and there is an additional parameter that allows you to load scene in a specific way. By default, we are making a switch. We are unloading one scene and loading a new scene on top of it, right? Loading a new scene. But what you can also do, you can load additive. So you're adding a new scene to the current one. That may be used, for example, to show maps and things like that. Okay, what we need this. We also use this scene switch script to make transitions in the scene. So, for example, when player hits specific object, we are making a transition to the next. So we can make transitions to next levels, right? And to use it, as I said, you have to attach this script to the object in the scene. Then in the button, you have to select this object here. right? In my case, it's a button. And then you have to select the function. So scene switch, start scene. That's it. You can save it, and that can be your welcome screen. Level 2 is basically any information you want. We can change the color of this text so it's more visible. Something more cheerful. Okay. Now, to make all this working, you need to make sure that your scenes are added to the build settings. Basically, what you do, you drag and drop the scenes to build settings. Now, on the list, you have names, right? Main menu, menu, main, level 2. And on this side here, 0, 1, 2, those are the indices that you can use to make the transition. If you want to change order, you can drag and drop your scenes, and automatically the index associated with the scene will change. Right, for our solution, those scenes have to be in order that you want to load them in your game. Right, so most likely will level 1, level 2, level 3, and so on, with the main menu being at index 0. Okay. So now if you start with the menu screen.
In the file you upload on Blackboard, it doesn't have most of the...
I will give you some time to read it. So that's the version from the lecture. If you start with the menu screen, when you click the start button, it should load the main game, right? And then there is an object somewhere in the scene that takes you to the final destination. As we discussed in the lecture, you can do some animations before you make the transition, right? So you can trigger specific animations in this function starts scene if you want. We are skipping this step in this game. We're not animating anything. Just switching the scene. Do you have the script? It's quite short, right? Okay. So, how does it work? Right, we start the game. We find our destination somewhere, wherever it is. Let's see. Level transition. Well, level transition is the other way. Fairly complete game and challenging. Let's go back to our main screen. Another thing that we want to practice today is using coroutines. Coroutines, if you remember, again from the lecture, are those pieces of the code that allows us to introduce, for example, delay. Basically, what happens in the coroutine has this ability to leave the execution and go back to the execution in the next frame, the same place, right? So for example, what I did during the lecture, I've added this door that open and close. Well, the door itself is not magical. We have this sprite in standard assets 2D sprites. It's just a white rectangle that is rotated 90 degrees. The whole magic happens in the script. And the script that we have is called door controller. Let me jump into this script and show you what happens there. Well, actually, what we will do, let me scrap this code. I will put it on the side. I will write this code with you as we go. Okay, so what with the door? The door has a oversized box collider. It extends towards the player, right? We will we'll use this door to block access to our level transition. So let's do it this way. The level transition, the box will be here, and the door will be blocking the way, right? So now, door has this oversized box collider, which is a trigger. And when we enter this trigger, the door should start sliding down or up. It's your choice, right? So what we have to do, we have to add void on trigger enter 2D to our door controller script, right? The parameter is collider 2D. This function will trigger opening the door, and opening will happen in a separate function. Private void open. I could do this, right? I could simply change the position of the door, right? Using transform, change the position of the door from open to close, right? Let's define two variables. So this is my close position, rounded. Yeah. This is my close position, right? Minus 1.3. I will define constants, float, closed. Now open will be, let's say the door will be sliding down. That will be my that will be my closed position. And const float open is equal to this, right? So we have open and closed position. Let's put it back to closed. Open the door, we could simply say if not is open, game object transform position equal new vector 2 position dot x. We are not moving the door on the x-axis, and game object transform position, sorry, and closed, sorry, and open. Then we should say also that is open true. And this function can be called in here. And will it work? Let's see. And it opens. But it's not the way that we want. We want sliding action. Can I simply change it here to the loop? For float p equals closed p more than open p equals p minus f. Would it change anything? We'll use p in here. In terms of execution, would this change anything? Would the door slide slower? No. Why? The whole loop is executed in one frame, right? So in one frame, we have door closed. We execute our function. We do it in the loop. But the next frame we draw as a door open, right? What we need to do, we need to have several frames with different position of the door, right? So this is a good beginning. Turn our open into a coroutine. And the coroutine simply returns I enumerator. And what we can do, we can here in the for loop, we can add yield return. Let's start with a null. And then we'll add a delay. I will also change the flag before we enter into the loop. Otherwise, the function will behave in a funny way because it will be trying to run it several times, so that the door will be jumping. This way, we disable the entrance to this function the moment we trigger the first open action. The only thing that we have to change, because we cannot call this function anymore this way. To have the full benefit of the coroutine, we have to start it as a coroutine. Okay? Saving the function. Running my game. Better? better. We can delay this action simply returning here new wait for seconds. And we can say, let's use 0.1 F. That's our delay. And we can run the game and see the result. And now you have slow motion. Now let's make this door to close automatically. After, let's say, 1 or 2 seconds being open, let's make this door to close the same way. So what do we have to do? We have to add new function, right? We have to add another coroutine. And now we know that it has to be a coroutine close. What will happen here? Well, same thing. But we'll start from open and we'll go to closed and we'll add and after this action is completed, we'll set is open false. Sorry?
So that should be after the close of the line. That should be is open. That is after the before the for about the for is open equals to class false, and this should be, I think, about the for like about.
No, because you want to change it only when the door is fully closed. Now, why in this place? Because we'll call this function in this if statement, right? We'll start coroutine close, and that will be the only place where we can trigger this function. We can add delay, simply adding another yield return new wait for seconds. Let's say this time it will be 2 seconds. Right, so you switch the flag immediately when you enter the trigger. You start the action, and you turn it back off, in this case, when the full action, open and close, is complete. Save. Opening and closing. Right? That's another funny thing. This object is a trigger, so it's not blocking me, right? I can fix it in 2 ways. I can wrap the door object in another object and add collider, or simply I can add another collider to this object. Add component, box collider, the regular one. And right now, I won't be able to go through the door. Any questions about this part? No?
So when you call the enumerator, right, it basically ensures that any code that executes from it happens on a frame.
Yeah. So the coroutine, that's the name. The coroutine allows you to leave the execution and go back in the next frame. So what happens in our loop? What happens in our loop? Each execution, each iteration is performed on a different scene, on a different frame. Right? That's why we can see the progress. Without the coroutine, you execute everything in between the scenes, right? Because the update that you have is happening in one run, and then the new frame is executed.
I'm just curious because so this effect is most notable on loops, essentially.
Sorry?
This effect is most noticeable on loops, essentially.
Mm-hmm. Or if you want to add some delay to whatever action, right? You have your code, and you want to add delay between two executions that you have two lines of the code, right? That otherwise would happen immediately.
Okay. So if you want like freeze the game
Or simply trigger some behavior as a result of action, right? But with a delay. So let's say I leave the room, and because I'm leaving the room, I want the light to go off, right? But after, let's say, 2 seconds, right? And then you don't need you don't need the loop. You just want this delay to happen. Yeah. And the good thing about this is that it doesn't block the game, right? It's not blocking. There will be blocking the execution. So everything simply would work slower, right? In this case, you don't block the execution. Okay, so it's time to add some enemies. We'll add enemy to the platform. Just like, let's make sure. Yesterday I was doing that, and we found out that those platforms are very uneven. They're not leveled. And the quick fix was simply to add the box collider around the whole thing. That kind of levels everything. Because when we are building those platforms, we're adding colliders to each of them separately. But what we need this. Okay. Let's pick our enemy. You have a headless snowman. You have horned snowman, and the regular one. Yesterday we've been working with this one. It looks like enemy. So let's use this guy. Let's add it to the layer. Well, we have to create a layer for him. We'll add layer enemy. And the layer will be used simply to detect collisions, not really collisions, but it will be used in line casting. Right? We'll create a mask based on the layer. Interesting thing about layers that I've been showing the group yesterday. Let's say right now we want to lock the background. what I can do, I can select the background object. It's quite a big object, right? There are few images that are added to this object. But sometimes when I try to select some smaller items from my scene, I select background instead, start moving background. It's not the way that I want to work, right? So what I can do, I can select the layer for my background or for any object in your scene, really, right? So let's say I will select ignore raycast. Yes, I want to change it for all the children. So they also are part of this layer. And now here on top in layers, what I can do, I can expand this combo. And there are those small locks. You can click on the lock. They're open right now. You can close the lock. Sorry. And when you try to click on the object, you won't be able to select. Let's zoom out and see. I'm clicking on the background, and I cannot select the background, which means that I won't be able to edit it right now. Right? So I'm finished with this layer. I lock it, and then I add other objects to the layer. What you can do also in this tool, you can make invisible. Sometimes when you have lots of elements, you want to just get rid of some stuff from the view, but still you want to keep it in the scene, right? In the final version. Not just a small hint that you can use building your final projects. Okay, let's go back to our enemy. Let's call it enemy. What do we want to do? We want to make this snowman to walk, or slide, really, on the platform, back and forth, but we don't want it to fall, right? So he should be smart enough to turn back when he's reaching the end of the platform, the edge. And to do that, we'll create a new script. C# script, enemy controller. We'll attach this script to our snowman right away. Here it is. Let's edit the script. So as I said, we'll use line casting. We have a platform object on the platform, and from this corner, we'll draw a line. And we'll cast the line down. And this line really will tell us if the snowman is grounded. If it's not grounded, the moment it just leaves the edge of the platform, it will turn and go the other way. Okay? So that's the idea. Sorry. Okay. Let me check if you can still see me. Okay, that's good. Let's edit the script. So first, let's define variables that we want to use in this script. We need to set the mask, and the mask will be we want to be able to set the mask from Unity. So we'll use serialized field for that. It will be private layer mask. That's the value, new class. We haven't been using it yet. Enemy mask. Other things that we want to set from is a speed, public float speed, not public, private speed, set it to 1. Now our private variables. We need a rigid body. Right, rigid body to D. Null in the beginning. We need transform. And also we need to know the width and height of the sprite, right? Because we need to know where to draw the line. So we'll have 2 more variables, float, width, and height. We could ignore height right now, but since we can use this, this enemy control also to detect if we are not colliding with a wall or something like that, we'll add it right now. And you will see how you can modify this later. Okay, so in the start function, we need to set up our class, right? So we need to get the body, game object, get component, rigid body 2D. We need to get a transform. Transform. And we need to get the width and height, but we cannot get it directly from the object. We need to ask sprite renderer for that, right? So first we need to get sprite renderer into our hands. Sprite equals this dot get component sprite renderer. From the sprite renderer, we can get simply by asking for bounds. Bounds extends x. That's the width. And height is similar, but it refers to y. Because we are using physics engine, we are using rigid body, our update should be fixed update. So let's start with the update function. As for our convenience, we'll use a debug draw line because we want to see where this line is really drawn and how it's how does it look like. Right. So first, to know where to draw the line, find out the beginning of the line, and we call it it's vector 2 line cast position. This position current position of the enemy, right? So position. We want to cast this to vector 2. Now, position minus, and we are moving down, and we are moving to the left, right? And trans dot right, again as a vector 2. Times width plus vector 2 up times height. We will use this value to simply draw the function. Draw the line. Draw line. Function takes the starting position, which is our line, cast position, and the end will be line cast position as vector down. To save this, you should see the line sticking out from your enemy when you run the game. But it's going wrong direction. Right? So we have to turn it into minus this, but this. Yes. I'm not mistaken. Nope. This should be minus. Now it's right. Position minus right vector minus, yes. Now it's time to calculate is grounded. The value for is grounded will be equal to physics to D line cast. There'll be some parameters. First, line cast position, that's the beginning of our line, plus vector 2 dot down, same thing as you see, is the second parameter. And the third parameter is enemy mask. This way, the line won't really get the enemy into account. Okay, so that's value for is grounded. Now you can do the same trick and project the line forward, and you can check if you're not getting into a wall or getting into another object or another enemy or the player, right? Okay, let's check now if not is grounded. If we are not grounded, we want to move. And if we are, if we are grounded, we want to move. But if we are not grounded, is not grounded, then we want to switch. Remember before, we've been using scale, right? Simply setting local scale to -1 was doing the flip. This time, we need to rotate, because if we do the scale, the image will flip, but the line will stay in the same position. And we want to have the whole object to do the flip. So we'll use rotation. Vector 3, current rotation is equal to transform Euler angles. We want to rotate around which axis? X, Y, or Z? Y, because we want to flip this way, right? Z would rotate us this way. Okay, so current rotation dot Y plus equal and then transform dot Euler angles equals current rotation. So we have the flip. Without any movement right now. Let's move it. Let's play. And it is doing the flip all the time. Why? It is doing it because our mask is not selected. You see the combo? When you select the enemy, the snowman, in the enemy mask, it says nothing. What we want to select everything and then turn off the enemy. So we will have default, transparent FX, water UI, except enemy. Let's check now. It flips, right? So it works. The last thing that we want to do, we want to make it moving. And to move our snowman, we won't use transform. We are using a rigid body, but we'll use velocity. Velocity is equal to body dot velocity. That's my current speed. That's my current velocity. I want to set the velocity on x-axis to be equal minus trans dot right dot x times speed, and we'll set it back to the body. Right, so body dot velocity is equal to velocity. Okay, if we save this and check, we'll find out that we don't have a rigid body attached to the enemy. We have to add rigid body to D, and we have to add the collider. Let's use the polygon collider. Let's try now. It's moving, 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 flipping. You can tilt it, push it, and so on. Poor guy. Now, if you don't want to have your snowman be tilting, wobbling, what you can do, you can select the object, go to the rigid body, and in constraints, you can freeze rotation on Z axis. Now, I cannot tilt it. Still should be able to push it, pull it, and so on. Any questions? Because you want to see the code. So this is the last lab in which we are talking about 2D. And we covered more or less all the topics that we need. In the next lab, we'll be talking about terrain and building terrain, how we can create terrain in Unity. And then we'll start building our 3D game. It will be a simple maze game with some terrain around the maze, right? So that's all, folks, in terms of 2D. Okay, we close this.